Hey everyone, we're picking up where we left off. This is page 108. Another piece of the puzzle in hypothesis testing is the type of test. So there's three types of tests. We're calling them left-tailed, two-tailed, and right-tailed. So the level of significance is always given. Come on, pen work. But you'll need to calculate the p-value. And the calculation depends on two things, the standardized test statistic and the type of test. So we'll need to determine the type of test. And to determine the type of test, it always depends on the HA statement. That's the key. So always look for the HA. So if the HA has this symbol, then it's a left-tailed test, right? And it's less than. So less than is less, left. Less and L, left, all start with L. Okay, I got that out. Okay, so less than is left. If HA contains the greater than symbol, that's going to be the right. And just like a right tail, here's the graphs. Okay, and then the two tail is just this symbol, right? And remember, the those are the three types of symbols you're going to see in the HA. It has to be one of those three. Less than, greater than, or equals. So that's it. If you need to decide the type of test, just look at the HA inequality, and that will lead you to one of these three. The p-value in all these is the shaded area, right? So the p-value might be on the left, might be on the right, or might be on both tails. So that's how it relates to the p-value. The p-value is the shaded region. Okie dokie. Let's do some examples. So for each problem, let's continue stating the HO and HA, specify which one is the claim, and then what type of test. And then let's see if we can draw the sampling distribution. Okay, so mean is less than 15. Right, that's an HA, right? Because it just has strictly less than. Again, you can go to that chart at the beginning of the section notes if that helps. This was the claim. Okay, so what type of test is this? Well, we'll look at the HA symbol, right? Less than, left tail. Okay, so this is a left-tailed test. And you can draw it out. It would just be the normal distribution with a left tail. Okay, that's it. Okay, mean is 718, so HO, HA, mean is 18 is an HA, HO I mean. HA would be not equal to 18. So notice that symbol. That leads you to a two-tailed test. And the two-tailed test would have two tails. How about a company claims that the mean life of its tires is at least 40,000 miles? Okay, HO, HA. You'll start getting used to at least. At least is that number or more, right? So that would be a greater than or equal to. At least is always greater than or equal to. That's that claim. HA less than 40,000, right? Again, look at the HA symbol always. It doesn't matter which one is the claim. You're looking at the HA. HA is less than. Here we're back to left-tailed test. Bet you thought we were going to do a right tail, huh? Nope. So, same as number 11. Now we have all of the pieces for a hypothesis test, and then so in the next section we'll get to running the whole thing. But to put it all together, let's look back at that professor's deck of cards claim. Right? So let's state the null and alternative hypotheses. Right? So we already did that in a previous problem. The claim was 0.5%. HA would be not 0.5%. Here the claim is the HO. Okay. Another thing you can say here now that we know, this is a two-tailed test. Okay. Find the p-value. Right? What's the p-value? Well, we found that, right? So the p-value was, and we'll have some more techniques to actually finding p-values, but we found it to be 0.001 on the previous handout page. Well, that was the first page of 7.1. That's when we calculated the probability of seeing 10 red cards. So the p-value is always based on the sample statistic, right? So that's, if you go back to that page where we did that, we saw that the probability of getting 10 reds in a row was very low. Right? That's what the p-value is. Okay. So if the level of significance is 5%, is the p-value unusual? Yeah. Right here we have the case where the p is less than 5%, 0.001 is less than 0.05. Right? This is comparing the p to the alpha. Anytime that happens, remember what we do: reject h sub 0. And then in the end, what we're going to do is put it all together. HO is the claim. We rejected HO. So if you look back on your conclusion table, you'll see there is sufficient evidence to reject the claim. Which makes sense, right? That we would reject because the probability of it happening is so low. I mean, there could be an error here. I mean, that actually could happen. The professor could be correct, and then we just happen to get 10 red cards in a row, right? So that there is possibility for error here. However, logically speaking, it's more likely, a lot more likely, that the professor's claim is false based on our sample. So that's what we're going to go with. Okay, so in the next section, we'll actually start running through the entire test and find ways to find p-values, roll in the normal distribution, and do a bunch of different hypothesis testing for means. So stay tuned for that. Okay, hope all's well. See you in 7.2. Bye.